Okay, so we're going to cover arrays and collections now, mostly arrays. So an array is an index set of the same data type. Could be a set of primitives, like a group of ints or a group of doubles or a group of booleans. Could be a group of objects, again, all the same type of object. Or it even could be a group of other arrays, as long as the arrays are of the same type. For indexing, we mean that every element of an array has an index. So think of it as basically being a file cabinet, a set of drawers. Every drawer has a number. And if you want to get the contents of a particular drawer, like find the value of the primitive at a given index, you just reference the array through the index. The handy thing about this is you don't need to distinctly name and reference each element. And in particular, it makes it very easy to loop through arrays. Let's talk about that. So suppose you needed to model three objects of the same type. Suppose, say, three ints. If you didn't have an array, you would need a distinct name for each one. For example, int x, int y, int z. And that might be fine depending on what you're doing. But if you wanted to do this with an array, you would do int, we call it array, equals new int 3. And then you would have an array of 3 int values. What's the difference for this? Well, the big one, suppose you want to check if any of x or y or z is equal to, say, 0. Without arrays, you would have to write it if x equals 0 or y equals 0 or z equals 0. Okay? With an int array, you can just set up a loop. So do initially Boolean, let's call it has 0. Right, if we want to see if any one of those is a 0, and we'll initially set it to false. Then we can do for int index equals 0, index less than array.length, index plus plus. And we'll say if array index equals 0, then has 0 equals true. Okay, so this set of lines here that will search through the entire array. At the end, if any 0 values in that array, it will return true. Now, for 3 values, yeah, it looks like this is a lot shorter. It's easier to write that. But imagine, right, for just 3 values, maybe arrays aren't that necessary. But imagine if you're talking about a very large array of millions of elements, just writing the if statements would be totally impractical. Okay? But for an array, you literally wouldn't change anything in the loop structure above. Okay? This whole line here, regardless of the size of the array, this simple code is going to work. So sure, if you have 1, 2, 3 variables, maybe arrays aren't necessary. But if you're doing giant batches of them, the ability to do this instead of some set of a million comparisons written out by hand with all the variable names, the array method is way better. Okay. So an array, in fact, is a special type. Basically, it's a custom class. Even though we don't interact with it like that in Java, basically that's what Java does behind the scenes. So it's a special type containing an index set of a type, which in effect means an array is like a new class with a set of same type data members. So if we had a class that we had 3 arrays, or 3 ints, we would write it class, let's call it numbers. And if we wanted to give it those 3 values, we just do it like that. Okay? In effect, what we're doing with our array is we're saying class, I guess we'll call it array again. And we'll say basically element 0, int, element 1, int, element 2, int. Okay? In effect, this is what we're doing. We're saying there are 3 elements in an array. They're all of type int. The way we actually refer to them is by numbers inside square brackets. So Basically, we would call it the element 0 at array of array, the element at index 1 of array, and the element at index 2 of array. Okay, but in effect, we're just making a custom class where all of the data elements happen to be the same type. And that's what an array is. So, another thing, unlike normal objects, an array has a length attribute holding the number of array elements. Because right here, when we write the class definition, we know how many things it has. But an array, we can set it to whatever number of elements we want. So part of what we do in an array, we have a length attribute. In this case, it would be 3. There are 3 elements in the array, so the length of it is 3. And remember, just like we did with strings, the last usable index is going to be 1 less than the length. Okay, so an array has the following specifications: a name, a type, and a length. So if I want to create an array and make it usable, I could do something like, again, int array equals new int, say 3 for the size. So I have the name, I have the type. The type is an array of type int. You need those square brackets there so Java knows it's an array. Has a name, and when I create it, I use new because I'm creating a new object to this class, and an int array with 3 elements. So I put 3 inside the square brackets. And then Java will know, oh, array represents a set of 3 ints. Okay. At declaration, an array gets specified by square brackets, either before or after the name. Unlike most things in Java, arrays, you have that flexibility. You can put the square brackets after the type but before the name, or after the name. The reason they did that is because back in the day, there were a lot of programmers who worked in C++ and were switching over to Java. C++ had one standard way to do it. The initial Java specification had a different way to specify the array. So at some point they said, yeah, let's just let it happen both ways because people are annoyed with all the errors they're getting when writing code. Anyway, when you create an array, you specify it with square brackets, and the size is included in those square brackets. In order to create the array and make it usable, you have to put that size value in there. The essential reason is this. If I'm making my class of a new array type, right? For example, if I make a class of numbers, I literally cannot write the class without specifying what data elements are in there. Likewise, an array is a custom class, and I cannot specify the class elements without saying how many things there are. So unless I know how many things there are, I cannot actually write this class. So I first have to say int length equals 3, and that's how I know what all data elements there are in this array. Okay, so he's an int, he's an int, and he's an int. Okay, so again, when you're creating an array, in order to make this thing usable, you actually have to specify the length. Now at that point, just by specifying the array, all of these ints have their default values, right? The default value of a class attribute is going to be 0 if I haven't specified it. So initially, when I create the array, if there are primitives, they're going to be zeros. If they are objects, they're going to be null objects because they haven't been created yet. I've only created the framework to store those elements, not the elements themselves. Okay, another thing in Java you can do, multidimensional arrays, basically arrays of arrays. Now in a sense, there isn't such a thing as a multidimensional array. They're just arrays that contain other arrays. If we have time, sometime down the road we can discuss the semantics of that, but basically arrays can contain other arrays, and that's what we mean when we say multidimensional arrays. So there's a shorthand declaration for those. Again, instead of individually declaring all the arrays, you can say, this array is an array of arrays. And to do that, you do a pair of brackets. And just like before, where we could put the brackets either before or after the name, same thing with multidimensional arrays. We could put both brackets ahead of the name, both brackets after the name, or we could split them around. Anyway, key point, in a multidimensional array, no secondary array can be given a size unless the primary array also has the size. So if I declare the first array, give that a size 100, I can say, okay, I have this array represents a set of 100 arrays. This one is not legal. I can say what this would mean is each array has 100 elements, but I don't know how many of those arrays I have. Again, if we think back how Java treats these as custom classes, if I have, instead of a single int, each of these is an array, right? I can write this part. I can say, oh, array consists of a set of 3 arrays. And here's element 1, here's the first array, here's the second array, here's the third array. I can do that. But if I haven't specified how many arrays there are, I don't have any framework to include these elements. Okay, so have to have the big array that contains all the others before I can create any of the little arrays that are contained. All right. Other thing, you can do what are called rectangular arrays, where each secondary array has the same size, but it's not required. Each of those arrays, for example, in this code here, each of the arrays could potentially have a different size. For example, I could say, right, this array is of size 6. This subarray is of size 8. And this array is of size, I don't know, 999,999, whatever. Okay? Each of these arrays could have different sizes. Reason is, in practice, that's often necessary. So, imagine if, for example, you were keeping track of a set of invoices. Every invoice lists a group of items that have been purchased. Well, of course, sometimes in an invoice, people might only buy one item, but people might often buy many. So in order to model that sort of problem, you need to have your arrays be variable sizes. Okay, so this we talked about arrays being objects. So yeah, arrays are objects for almost every purpose in Java. Okay. And this we've already covered, so that's fine. Again, though, I will mention creating an object belonging to a null object is not valid. So in this case, we've created these arrays. But if I try to create one of these arrays without specifying the outer array first, in a sense, I'm saying that this object would be null, and I would try to create a null. I would try to create an attribute array within that null object where you can't access a null object. So, or an attribute of a null object. So, same thing that basically if you have a two-dimensional array, you have to create the big container array first before you create any of the arrays within it. Okay, indexing in arrays, just like strings. So the first element in an array has index 0. If you have an array of n elements, the last index is n minus 1. And likewise, every array has a length element containing how many elements it has. So, simple loop to initialize a large array of strings. So suppose we have an array of strings called words, and it has 1,000 string elements. If we want to set all of those initially to empty strings, we can loop through it by starting at index 0 and continuing as long as loop is less than words.length. Basically, so we're going to initialize the string for every element in words. And then after each pass through the loop, we increment loop by 1. So the first time through, we initialize the 0 element to an empty string, and then we increment loop. Second time through, we initialize the element at index 1 to an empty string, and so on, until again we get to the very last one, where this loop is 999. We add 1 to it, it's 1,000. We go back up again. 1,000 is not less than the length of words, which is 1,000. So we're done, and we've initialized every element in the array. Okay. Just like strings, remember strings are immutable, which means they can't be changed in place. You can create a new string using an old reference, but you don't actually change the old one. Just the old one would typically become garbage. Same thing with arrays, because arrays are essentially this kind of custom structure. If I want to make a new size, I have to create a new array, and that new array is going to be located somewhere else in memory. So basically, I have to create a totally new one. Okay. But of course, I can change the individual array elements themselves. Anytime I have, just like, let's see. So if I have this value, we'll go back to our simple array. So we just have int 0, int 1, and int 2. Somewhere in code somewhere, right? So initially all these would be 0. I'll even just code that in. But if I wanted to change one of those elements, then somewhere in the code, I could write something like, array 1 equals 2, and maybe array 2 equals, I don't know, 45. And I would just change those values and it's no big deal. The array says, oh, these are all ints, they occupy the same space in memory. I can overwrite them with no problem because I know whatever I overwrite them with is also going to occupy that same space in memory for an int 4 bytes. Okay, and of course, changing one array element doesn't change the contents of any of the other elements. So again, think of it like a filing cabinet. If I open one drawer, change what's in that drawer, I don't affect any of the other drawers in the cabinet. Okay, other problems though, resizing arrays is a little bit tricky. You cannot directly remove or add new elements to an array without also creating a new array. So we'll give a couple examples for that. Basic process is this. If you want to resize an array, you're going to create a new array of the same type, but with the desired size, whether bigger or smaller. Then, any elements you're retaining, you want to keep. So you want to copy them to the new array. Then last, the original array points to the new one in memory. So essentially what you're doing is something like this. Imagine if I have an array, let's keep it simple, let's have it be 4 elements, and I want to add one element to the array. Okay? So what I would do first, so here's the old array, and here are the elements 1, 2, and 3. So what I would do first, I create a new array, and I would give it the same 5 elements, right? So old array, size 4, this array, size 5. I'm going to make a new array that basically looks like this, but with another element added on at the end. Then, okay, I add on the new element. So, automatically, how does this work in code? I want to move it around here. It doesn't want to really, there we go. Doesn't want to get grabbed. Okay, so suppose I have some old array. First I would say, and let's say it's ints. So int new array equals new int with size old array plus 1, right? It's going to be 1 bigger. Then I write a for loop to copy everything over from the old array to the new one. So int index equals 0, index less than old array dot length, and index plus plus. Okay? Then within that loop, I just copy over the old elements. So I say new array at index, the element at index is equal to old arrays element at the same index, right? Because I'm just copying them over one at a time. So just like dot, and dot, and dot, and dot, and all those are over. Then at the last one, I give it whatever new value I'm getting. So at this point, new array index 4 would equal 0. I haven't assigned it yet. So if I wanted to assign it a new value, right, whatever that value might be, I would say new array at index 4 equals new value, whatever that is. Okay, maybe I received it as a parameter when I called the method. Okay, and then I'm done. Then I have the new array with the extra element in there. Easy. Oh, last thing, if I still want to call it old array, I would say old array equals new array. That way I'm reusing the reference, right? So I can still, if I need to, I can still refer to old array, but in fact now it's pointing to the new larger array instead of this one. This array will now become garbage. That's how you expand an array. Pretty simple. So there's an example here, same code if you want to look at it. And we'll do this one, compressing after deletion. Now suppose I have a slightly different problem. I'm going to swap this around a bit. Okay. Let's say my old array is my new one, and vice versa. Ooh, if I can grab that. Okay, and let's say I want to remove index 2. Okay, he's gone. He's not going to be there anymore. So what do? Well, I need to copy these indexes before the removed index into the same location. So 0 goes to 0, 1 goes to 1. The indexes after the one I've removed, the element I've removed, I copy it into an index 1 less. So 3 goes to 2, 4 goes to 3. So essentially what I do here is I have 2 loops. So first part, right? First I create a new array. So new int new array equals new int old array dot length minus 1. By the way, notice that length is an attribute different from string. In string we call a method, but for arrays we just read an attribute. So here I've made an array. New array is going to be 1 less. Okay, let me edit those, because those are no longer true. So the old array, size 5, and the new array, size 4. Okay, so first thing, I copy all of the elements. So the index to be gone, we'll call that index to be removed is gone, is named gone. I'm just going to call it gone. So first thing, copy the elements that stay in the same location. So int index equals 0, index less than gone, index plus plus. Okay, and for everywhere in there, I just say new array at index equals old array at index. And that's fine. Okay, so at this point, I've copied over all the indexes that stay in the same place. For everything after gone, I start at gone plus 1. So int index equals gone plus 1. Index, I keep going while index is less than old array dot length. And then I increment index each time through. And for every point in there, I wonder if I can stretch this all out into one line. Maybe I can. There we go. Okay. So for every element in there, I say new array at index minus 1, right? Because I copy into one lower index equals old array from index. Okay, so initially if I'm copying from index 3, so index is 3, I want to copy that into 1 less. So I'm copying it into index minus 1. And likewise, if index is 4, I'm going to copy it into index 4 minus 1 equals 3 in the new array. Okay, so at this point, everything's copied over, and I'm actually done. If I want to, the last thing I need to do is copy over the reference. So I say old array equals new array, and just like before, old array becomes garbage because the old array reference now points to this new array that I've just created. Okay. Again, code example here, compression after deletion. Last thing I'll cover, searching arrays. Quite often you'll have methods that search an array for the index that stores a matching value. For example, if I want to find if in an array of type char here, there's a particular char value C, well, initially I set an index. This is the value I'm looking that might hold the index where the match is found. Initially I set it to -1. I can use that as the default value not found because -1 is never going to be a valid index. Same thing with index of in strings. -1 is the value that you get when the method doesn't actually find a match. So it returns -1, which again, we know it cannot be a valid index. So to loop through the entire array, check every element. We start at 0. We go through to text.length. Text is the name of the array. And after each iteration, we increment loop by 1. And if we find a match, so if char C equals the value at loop, so if C equals text at element loop, then we simply return loop. We return the index where we found the match. Otherwise, if we make it through the whole loop and we didn't find anything, well, we know that index is still -1. So we just return -1. Okay. Last thing, very quickly, there are a lot of classes that Java made that simplify some of these mechanics of working with arrays. So once you've figured out how arrays work, there is value in knowing how arrays work, but people use different ones, like in particular ArrayList is a popular one because it automates all the process of adding new elements, removing elements, sorting arrays, things like that. But at the nuts and bolts level of Java, ArrayList does exactly these same things that we talked about right here in the preceding slides. It's just, it makes it a little simpler for a programmer. But because it's a general purpose way to do it, it actually also runs a little bit slower. So if you want to have really optimized code in Java, you're best off using just raw arrays. But if you're kind of slapping something together and it doesn't have to work too well, just has to work well enough, then yeah, maybe something like ArrayList is totally fine. All right, and that's all I got for you.